Well, if you want to be at the apex of seeing things clearly, son, you should watch some of Matrix After Queries. Fear me clearly. It's getting a little eerie. I be still. Okay. So you're given an integer n and a zero indexed two-dimensional array queries where queries of I equals type of I, index of I, val of I. Okay. So things that were given in this problem, we are given integer n. All right. And we're given queries of I equals type of I. What does that mean? I don't know, but we're dealing with queries in this problem where each query defines some kind of operation, something to do with n. Okay, so type of I, index of I, value of I. All right. Never a bad idea to just write stuff down because, sometimes there's a lot of fluff. There's a lot of, non-essential information within the problem. So try to just parse out the most essential components. Initially, there is a zero indexed n by n matrix filled with zeros. Okay. So for this integer n, we're going to create some matrix that has dimensions, n by n. Did I screw that up? I don't know. Imagine that's a square, and I believe it is, right? And this thing has dimensions n and n, so that's an n by n matrix, which initially is filled with all zeros, right? Da-da-da-da, da-da-da, da-da-da-da-da-da, that, right? Specify this thing is filled with all zeros. And for each query, you must apply one of the following changes. Okay, so you're given a type I. So if type I equals 0, set the values in the row with index 0. So if type I, so I'm just going to put type equals 0. Then we go this direction. Meaning that if type I equals 0, we set the values in the row with index I to val. So if type I equals 0, we're setting a row at some index, right? So index 0, index 1, index 2, right? So this was index 0, 1, 2, 3, 4, whatever, going down, right? So we'd set that row to the value specified here, right? So if we had query I, por ejemplo, for example, queries of I equals 0, I value. If this was index I, for example, we then set all of these values to V, right? And then the flip side is if type I equals 1, if type I equals 1, then we're just going to set the column, associated column, right? So I think that's pretty, intuitive how that's going to work, right? So instead of setting so you go to index I in this direction, right? So if it was index I, so 0, 1, 2, 3, 4, whatever I is, and then you set all those values to the value V. Okay. So what we're going to do then is return the sum of integers in the matrix after all queries are applied. All right. So we're going to get all these queries, and then we're going to set all the values corresponding to each of the indexes and each of the types. And at the end, we want to sum that matrix, right? Now, let's go ahead and do an example first, and then we'll think about kind of what the consequences are of this system, okay? So this system, there's going to be 1, 2, 3, 4, 5 changes. So let's just make a 5, and it's a 3 by 3, right? It says n equals 3, so there's a 3 by 3 matrix, right? Because n specifies this size of the matrix. Okay, so let's just make those 3 by 3 matrices. And, I don't know what happened there. All right, so 3 by 3 matrix, and I'm just going to duplicate it so we can see the consequence of each operation. Just kind of how they're in this example, but we'll do a little bit more color coding and analysis so that it's maybe some sort of information about the nature of the solution pops out to us. It may not. This is definitely one of those problems where it kind of requires this little trick right? This kind of way of reassessing how you think about the problem and reassessing it will allow you to then kind of discover the solution. So with that said, let's just go ahead and get right into it. So initially, everything starts at 0, right? Right, it's an n by n matrix that starts at 0. And then we start going through these operations. So our first query is 0, 0, 1, right? So I'll write that down here. So I'll put my queries at the bottom here. Queries. Spelling in English is so hard, especially when you're an idiot like me. Okay, so we have query 0, 0, 1. So what does that mean? Well, that means we're going to set the row, because the type is 0, the index is 0, and we're going to set it to the value 1, right? So it starts out before we change anything, right? It's all zeros. And then we apply this operation at the 0th row, because the type is 0, and we set it to value 1, okay? So then these values become, I'm screwing up, these values all become 1. All right. The next thing we're going to do is the query 1, 2, 2. All right. So this one is a bit different. And I'm putting it in the wrong spot because there's something wrong with my brain. 1, 2, 2. Right. So the matrix before we started was 1, 1, 1, 0, 0, 0, 0, 0, 0. And we're going to change a column now. Right, starting at column 1. We're going to go to column 1 and we're going to change. Whoa. That's weird. We're going to go to column 1 and we're going to change the value to 2. Right? So So we do type 1, we go to column 2, so 0, 1, 2, and we change the value to 2. Apologize, a little bit of a brain freeze. Now, you'll notice what happens here is since we're changing column 2, this 1 now becomes a 2, right? Because we overwrite the previous value in the system, right? So now this value will become a 2. And then let's not play this game again of copying. Let's just duplicate this and copy it right over. Okay. So now this 1 the hell's going on? I clicked some button I'm not supposed to click and things got all out of whack here. Very embarrassing. Okay. So I think that's better now. Right? All right. Apologize about that. Making a lot of mistakes in this video. All right. And then the next value we're doing is 0, 2, 3. Okay. So 0, 2, 3. So what does that mean? We're going to row 2 and changing the value to 3. Okay, so let's go to row 2. Now you'll notice that overwrites the once existing 2 to a 3. And then finally, we're doing 104, 104, 104, 104. So that means we're changing a column 0 to 4, right? And again, let's just duplicate this over. And then we're changing a column 0 to be all 4s. All right. So then these 1s and these 3s, they're going to get overwritten. And they get changed to the value of, I don't know, 4. So then the final answer is just what's the result of, this query? I mean, what's the result of all the values in this? What's the sum of all the values in this matrix? Right. So we have 4, 5, 7, 11, 13, 17, 20, 23. Right, so the sum here is 23. Voila. Now, we could go again for another example, but let's not do that. I think this is a sufficient starting point to kind of lead us to the solution. You'll notice that the most obvious solution would be to just go make a matrix, and then for each query, just write each of the rows, each of the columns for each of these corresponding queries like so. And then at the end, just return the sum, right? But that kind of simulation brute force approach is going to be far too slow given the constraints, right? Because we're going to have 5 times 10 to the 4 queries, right? And for each query, we're going to have to do n operations because we're going to have to change n values in the matrix. And there's 10 to the 4 possible values in a row or a column, right? Because for each query, we were going to have to paint a row or a column a brand new value, right? Right? Each time we get a query, we have to paint a whole row or we have to paint a whole column. So if there's 10 to the 4 queries, 5 times 10 to the 4 queries, and for each query we have to do n operations for the painting of a row or column, that's 5 times 10 to the 4 times n, which can be 10 to the 4. So that's 5 times 10 to the 4 times 10 to the 4, 5 times 10 to the 8. That's going to definitely give us a time limit exceeded error. So that's far too slow, right? So it's never a bad idea to look at these constraints, because maybe, you know, if you're looking at this and it's like, maybe the obvious solution is the best solution. And if it was, well, it may still not be, but it will pass if it's, you know, less than 10 to the 6-ish, right? But if you're looking at the constraints and in the worst case, it's, you know, 2 orders of magnitude, right? It's 100 times greater than that 10 to the 6 mark, which it is in this case, right? Because 5 times 10 to the 8, then likely the simulation isn't the approach you're going to use. Not likely, it definitely isn't, because it's going to exceed the time limit exceeded error. And you need to think about some better runtime solution, right? So what is that solution? Well, like I said earlier, you need to think about, you got to be able to think about a different way of looking at this problem in order to determine kind of how it can be solved, right? And in the first way is, well, you know, I guess the first observation, right, is what? Well, you'll notice that some of these values, right, they get cut off. Like, you know, one way we could do this quickly is we could look at each query and we say, well, this value here, this query, right, it's going to provide me with n ones, n times 1, right? And this query will provide me with n times 2 to my solution. Meaning that, you know, if I'm going to look at how much each query will add to my final solution, because my final solution is going to be a sum of all the values of the matrix, right? At this point, when I paint a 1, right, it's going to paint n1. So this is going to give me 3 to my solution, plus 1, plus 2, plus 3. This is going to give me n times 2, right? Because it's going to give me 2 plus 4 plus 6 total points to my solution. And this 3 will give me 3 times n, and this 4 will give me 4 times n, right? So then you may feel, you know, inclined to say, well, what I'll do is my solution is just look at each query, look at the value, multiply by n, and add it to my solution, right? I'll just add n times 1 plus n times 2 plus n times 3 plus n times 4, and that's my solution. Sort of. The issue is, though, is that when you paint over with a new value, you can possibly lose previous values, right? When I paint this 2, well, I'm no longer getting 3 from these 1s because one of the 1s now becomes a 2. Same here, right? When I paint these 3s, I'm losing one of the 2s, right? So I have to subtract out a 2 and add in a 3. When I do the 4 here, I have to subtract out a 3 and a 1 and add in these 4s. So it's not like I'm always getting all the values associated with the query, because it could be overwritten at some point in the future, right? So I guess you know that every time you use a value, it's going to have n, there's going to be n of those values in your array until it gets overwritten, right? The only time that isn't true is with the last value, because the last value is the last thing to be painted, so nothing will ever be painted over it, right? And anything that comes before it will be painted over by this 4, right? These 4s are set in stone. That's the last thing that gets painted in this array, and anything that comes before it will be overpainted by these 4s, right? So when I look at the solution, maybe it's better to look at this array backwards and say, well, when I paint these 4s, I know for sure that these 4s are going to be in the solution at the end, right? Then I don't need to actually paint the matrix. I'm going to say, well, that's going to give me 4 times 3 points equals 12. So that's going to add 12 to my solution. And then when I go to the previous value, in the system, that'll be the next to last thing that's finally painted. And that'll be painting a 3 across the bottom. All right, a 3 and a 3. But it's not going to paint over the 4 because since I'm going now from right to left, right? If something's already there, that's the last thing that's going to be there. So this 3 does not cover it, right? Instead, it gets covered by the thing that comes after it. So I know the future now, right? Now when I'm painting this 3, since I'm going backwards in time, right? I'm going in the opposite direction of which the queries are executed. I know, okay, if I see something, that gets painted after me. So I'm not going to go over it because actually, in reality, since it comes after me, it goes over me, right? I'm not going to paint over the 4 with a 3 because I know since I'm going in reverse, the 4 comes after me. So the 4 actually paints over the 3. 3 doesn't paint over 4. 4 paints over the 3. And what does that mean for the solution? Well, that means I'm going to get another 3 times 2 to my solution, which is plus times plus. So this is 6. This is 12. And then when I look at the 2, I'm going to play the same game again. Right? So when I paint the 2, I'm going to encounter this 3. And I'm going to say, okay, well, this 2 actually isn't going to cover the 3 because the 3 is painted after. And then I have the 1. Oh, the 1. So that means I'm going to get 2 times 2 to my score. Right? 2 times 2, which equals 4. And then finally with the 1, you get to really see this point exaggerated, right? Because the 1 wants to here, but he knows, okay, this 4, I don't know when it comes, but it comes after me, so I can't cover it because it's going to cover me. Nothing covers this spot, so I'll take it. And then this 2, this comes after me, so I can't cover it. And that'll give me 1 times 1 to my solution. So 1 times 1 equals 1. And then if you add those up, we get, 10, 20, 10, 22, 23, 23. So this isn't, is this really better, right? The weird thing with this is like, okay, you just thought about this problem in a different way, but it hasn't really improved your runtime too much. It has given you kind of an inference about the problem because when you go backwards, you don't need to cover the whole cells, right? So it does give you some information about the problem. Now let's specify the directionality of this. Right, these go this way, while I'm painting these in the backwards direction by processing the queries in reverse. Right? So I guess what I'm trying to get at is, can we use this information to say something about the problem? Well, I'm still having to go through this manually, right? But when I'm painting the 3s, is there a way I can know the number of 3s that I'm painting without having to actually look at the array? Right? The way that I know is, well, if I'm, generally, if I'm painting a column, or let's say I'm painting a row. So let's look at this generally and see if we can make an argument, right? Let's say I'm painting some row in this big system here, right? Okay, so I'm painting this row. I'm painting some row in this system. All right. So if I'm painting these values, some value v. Well, how many of these am I going to... Oh my gosh. Oh, sorry guys. This is really frustrating me. Okay. How many of these am I going to paint V? Well, ideally, I think, okay, if there's n values here, sorry, I'm just thinking out loud here. If there's n values here, I'm going to try to paint all of these V, right? But everything that comes after it is going to go over it, right? Does that make sense? Like, there is possibility that things end up coming through here and blocking these values out and replacing them with new values, right? Other rows won't. If other rows are colored, they won't affect these V values. They won't affect the score, right? but only unless it's a value that paints over it directly, right? But any other row won't affect my values. The only thing that will affect the painting of these values are other columns, right? So if I'm going backwards, right? If I'm going backwards before I process these V's, and I say, and I do some paints here. So let's just say there's values that get painted. So maybe, you know, these X's get painted here, X just corresponding to some value. And then there's another set of values over here. You know, and then there's another set of values over here. When we paint a V at this row, a V and a V, how many V's are we going to paint? Well, we're going to paint n V's minus the number of columns that have already been painted, right? Because this column is in the way. And since I'm processing in reverse, this column is going to be colored. It's going to go over the color that I'm coloring, right? So I'm going to paint V's everywhere except where these X's are. So that means I'm going to paint I'm going to paint V's. How many V's am I going to paint? I'm going to paint n minus the number of columns that I've drawn so far, right? And that's the same thing. What if I'm painting a new column with value V? Well, if I'm painting a new column with the value V, right? It's the number of rows that have been printed so far, right? Because I'm not going to, if those come after me, they're going to go over me. So when I'm painting a row, the number of columns that have already been drawn are going to affect the number that I get, right? So in this example here, right, how many rows and how many columns have been drawn so far? So let's do that here. So rows and columns. Row, column, row, column, row, column, row, column. All right. All right. So we get 4 times 3, and 3 is n, right? Because there's been 0 rows and 0 columns. But at the end of this, there's going to be 0 rows and 1 column, right? 1 column filled. So then when we try to paint this row, well, one of the columns has already been drawn. So we have to do 3 is the value we're doing times n minus 1 because there's 1 column in the way. And now there's 1 row and 1 column. When we paint this 2, well, this 2 is painting a column. But since there's already been a row, we can only multiply it by n minus 1. So we have now 2 columns, 1 row. And then when we try to paint the 1, now you really see what's happening here, right? Because when we try to paint this 1, well, it's the case where how many columns are there in their way when we're trying to paint this row 1? So we try to paint this row 1, right? But then there's values in the way. So how many values are going to be in the way? Well, there's 2 columns that have already been painted. So now there's only 1 spot, right? There's n minus 2 spots now where I can put this 1. So now there's 1, which is the value, times 2 minus 1, minus 3 minus 2, which is 1 values that I can actually paint over. So now there's 2 rows, 2 columns, etc. Right, so for this problem, what we need to do is just keep track. We go backwards. We keep track of the number of rows and number of columns that we painted, and that'll tell us how many new values we'll get to add to the system, and that'll contribute to this multiplication here, right? So for each system, what I'm really going to do is I'm going to say, unless it's the same row, right? Because if I'm painting the same row over, well, then it's already been painted over. So I can't paint over the same row, but if it's a different row, then it's just the number of columns that I'm looking at, right? So hopefully that point makes sense. So what we'll do to keep track of this is we'll keep